there's two options. If it isn't greater than, or greater than or equal to, that is what we call an or. Okay, absolute value tells you how far away from 0 something is. If I say the absolute value of x is greater than or equal to 5, that means I need everything that's 5 or further from 0. Okay, so I could be here or that direction, or if you're at negative 5, isn't my distance from 0 still 5? And if I want to be more than that, I would have to go that direction. So if it's a greater than, these are ors. So they will go two different directions at the end. If it is a less than is telling you your distance from 0 is, in this case, 8 or less. If that is the case, then we have to be within 8 units of 0. So I could be from 0 to 8 or from 0 to negative 8. So if it's a less than, that is an and. Right? So what I like to think, if it's a greater than, we have an or statement. Less than is like an and. That's than. Trick to help remember it. That's an and. So greater than, we will have two separate answers. If it's a less than, our answer will be in between two numbers. So, when we solve these, our steps, first we have to isolate the absolute value. We cannot do anything until the absolute value is by itself. So that has to be where we begin. Before we do anything else, rewrite the problem so absolute value is by itself. Then we are going to rewrite the problem without the absolute value symbol. Okay, then we will solve both and graph our solution. So, let's take a look at this one. If I say the absolute value of x is less than 7. So first thing I want you to look at, is the absolute value by itself? Yeah. I mean, I don't have anything else on that side with the absolute value, do I? So we're good there. So the next thing I want you to ask yourself, is this an and or an or? And. Less than is an and. I want you guys to write that down. And. So I see the less than, I know it is an and. We talked about different options for that, but typically when we had and statements, we rewrote it as one big inequality. Okay, so what we're going to do is we keep this, the absolute value of x is less than 7. I'm going to drop the absolute value, so I'm just going to say x is less than 7. And then, when it was an and, it was in between 2, so I'm going to put another less than and a negative 7 on the other side. So it's between negative 7 and positive 7. If my distance from 0 is smaller than 7, it's somewhere between negative 7 and positive 7. So my solution, would they be open or closed circles? Open at both positive and negative 7, and we are graphing in the middle. All right, number 2. If I look at this, first question, is the absolute value on a side by itself? Yes, so we don't have to do anything special there. Next question, is this an and or an or statement? Or. So we need to rewrite this problem. So, when it is an or, I want you to write down or so I know you're thinking about it. Less than is an and, we make one compound inequality. When it's greater than, when we graph it, it's two separate ones. So we are going to write two separate ones. The first one, all we're doing is dropping the absolute value. The second one, we flip the sign and make it a negative. If you are more than 4 from 0, you can either be bigger than 4 or smaller than negative 4. So when you write the second one, it flips the inequality and makes it a negative. Alright, so and, we make one big one or two separate ones. Alright. Number 3. When I look at this one, is the absolute value on the side by itself?
No.
I do have other stuff in the absolute value, but do I have anything outside my absolute value? So it does count as being by itself. We're going to have a little more work here, but I can go ahead and separate it. Is this an and or an or? Or, because great or than. So with the ors, we do two pieces. The first one, all we do is drop the absolute value and rewrite our normal problem as normal. For the second one, what did we do up here? We flip the sign and make it a negative. Alright, so now we solve these. So we have 2 to solve, just like we were looking at yesterday. So we get x is greater than 7. This one, if I add 1, we get x is less than negative 5. So these are or, so we expect them to go two separate directions. Open or closed circles? Open. So greater than 7 starts at 7 and goes to the right. Less than negative 5 would be an open circle at negative 5, going to the left. Number 4, I still have the absolute value. It's on the side by itself. Is this and or or? And. Less than is and, greater than is or. Does everyone know how I'm deciding and or or? Okay. With or, we separate into two pieces. With and, we are going to make one big one. So we drop the absolute value. What else do I need on here? So what we put is a negative 7 and another less than on the other side. So that makes it a compound inequality. All right, so now if I'm solving this, we have to subtract 2 from everything. So I get negative 9 less than or equal to x less than or equal to 5. Open or close circles this time?
Close.
Okay, so starting at negative 9, ending at positive 5, we are between them. Alright, so depending on if it's less than or greater than, that changes how we set up the problem. Are there questions so far on how I am setting these up? We're just going to keep practicing until we've got it. Let's go to number 6. This one is different. When I look at it, on the side with the absolute value, don't I have a number outside my absolute value?
Yeah.
So the first thing I have to do is get rid of that. So I'm going to add 1 to each side. So then I would have the absolute value of x plus 3 is less than 6. Now it's like the ones from the front side. So we decide and or. Less than means and. How do we write the less thans? One big one. We're going to say negative 6 less than x plus 3 less than 6. Okay, now we're solving that compound inequality. So we subtract our 3's. So we have negative 9 less than x less than 3. So it's an and. We know that just means it's in between the two numbers. No equal to mean we have open circles. And we're going in between the two. Let's go to number 8. So if I look at this, I need the absolute value by itself first. How am I going to get that absolute value by itself? Okay. If you multiply by a negative number, it switches the sign. So we have the absolute value of 4x minus 8 becomes greater than or equal to 12. This is the step I look at to decide and or. So we're looking at it when the absolute value's by itself. This is a greater than, which means or, two separate ones. So the first one, all we do is drop the absolute value. For the second one, what do we do?
Flip it and change it to a cluster.
4x minus 8, we make it a less than or equal to negative 12. We have two separate pieces to solve. Add our 8. Get 4x greater than or equal to 20. Divide by 4. So x is greater than or equal to 5. That's a closed circle at 5 going to the right. This one, if I add my 8, get 4x is less than or equal to negative 4. Divide by 4. So x is less than or equal to negative 1. So that's a closed circle at negative 1 going to the left. Alright, so the big thing on these, get the absolute value by itself, and then you have to decide which type it is. Is it an and, where I have to write one big inequality, or is it an or, where I do two separate ones? Let's do a couple more together. You guys need to walk me through these a little more. So, somebody that hasn't really volunteered yet. We have to begin by getting the absolute value by itself. So what would I need to do first on number 9? Nicole, what's my first step? Well, what do you think if you're trying to get this by itself?
I took out the 10 and the 3 and then moved over the 47.
Okay, the 10 is multiplied with this, so let's get rid of this minus 3 first. So the opposite of subtracting 3 is to add 3. So yep, on the right track, we have to get rid of that 10 and 3. So I have 10 times the absolute value of x minus 4 is greater than 50. All right. Noah, how do I get rid of the times 10?
Multiply.
Yeah, I mean, I think you mean the same thing, but we could just divide by 10, right, to move it over. So the absolute value of x minus 4 is greater than 50. So now the absolute value is by itself. So we have to decide, is this and or? Keaton, do you know which one it is?
Or.
All right. So ors, we do two separate ones. Julius, what's the first one going to be? Yeah, you don't have to even solve it yet. Just tell me how I'm going to write it. So we had it with an absolute value, so when we get ready to solve, we need our two separate ones. So we just drop the absolute value. That's all I was asking for there. He didn't have to solve it quite yet. That's the first one, nothing changes. Or, for the second one, Holden, what do we do? How do we write the two pieces? The previous one. So the first one, you just drop your absolute value. What did we do for the second one? Flip the sign and flip the inequality and make it a negative 50, less than negative 50. Okay, so now we solve each of these. So we get x is greater than 54. This one, x would be less than negative 46. Oh, hold on. I have a mistake, don't I? Why didn't you guys say something? Yeah, I wrote divided by 5, but did I ever divide it? No. See, I did that on purpose just to see if you guys would speak up, and you didn't. You all failed for the day. That was totally intentional. All right, so now 5 plus 4. So x is greater than 9. Negative 5 plus 4. X is less than 81. Does that look better? You guys slightly less confused now? All right, greater than 9. I need to add a point. That would be an open circle at 9 going to the right. Less than negative 1, so open circle at negative 1 going to the left. Or, so we expect two separate pieces. All right, that one was a little rocky. Let's do the next one. All right, first step. We have to get this absolute value by itself. Esther, what could we do here? If I want to get the absolute value by itself, what do I have to move first?
Minus 11.
So I have 1/2 times the absolute value of 4x minus 4 is less than or equal to 4. Right. Kaden, how do I get rid of this 1/2?
No.
Divide by 1/2 or multiply by 2. Either way will get you there. So 4 divided by 1/2 is the same as 4 times 2. And we get 4x minus 4 is less than or equal to 8. All right. Bailey, is this an and or an or? And. Less than is and. When we set up an and, we make one big inequality. We keep the 4x minus 4 is less than or equal to 8. But Riley, what else do I need? Yeah, just like we did on all the others. So you guys might need to keep your notes out when you're doing the homework today. When it's an and, we put it in between the positive and the negative. Okay, now it's just like a problem that we've been solving. Okay, when we have a compound inequality, we have to get this x by itself. So, Blair, what would I do first?
Plus 4.
Do it to all sides. So we get -4 less than or equal to 4x less than or equal to 12. And then Jenna, what would I do to finish? So we have -1 less than or equal to x less than or equal to 3. So it's an and. You get in between the two pieces. Alright, so the big thing is that step where you rewrite it without the absolute values. That's where we are having the most problems. And you need to just think back to this. If it was a greater than, we had two separate pieces. Greater than or equal to 5, or you flip the inequality and make it a negative. So the second one, flip the inequality and make it a negative. When it's an and, the first part stays the same, but you put another less than and a -8 on the other side. That's the step when we write it without the absolute values. I want you guys to work